Hi. So in this video, we'll see how string permutations can be done using Java. So to begin with, we'll go through a little bit of theory about what string permutations actually are. So let's say you have a word ABC, then string permutations for that could be rearranging A, B, and C in all the orders possible. So that would be ABC, that would be ACB, BAC, BCA, CAB, and CBA. So imagine if you have a word called hello, then you have these possibilities. H will be first, then we'll switch out the positions of O and L, and then we'll switch out similar positions again. So you can see the first one and the third one are similar, but actually the third L in the original hello, the third letter in the original hello, and the fourth letter in the original hello both are L. So they have been interchanged, but to us it seems the same. All right. So we'll go through a recursive approach for uh, computing permutations of any given string. So we'll go with our example of A, B, and C. So here we have three choices. We can pick either A, either B, or either C. So we'll go through each of these choices. So first we'll go and pick A. Now we are left with two choices. So either we can pick B or we can pick C. We'll go with B, and now we have only one choice, so we have to pick C, and that gives us A, B, and C. Now to go back, we have picked A, and we have a choice. We had a choice of B and C, but we already picked B and went through that way. So we'll pick C, and then we have only one choice, that's B. So that gives us ACB. Now, going back to the first step, we had a choice of A, B, and C, but we already went through the root of A. So we'll pick B this time, and now we again have two choices, A and C. So we'll pick A, and now we're left with only one choice, that's C. So that gives us BAC. Now we'll go back to picking B first, and then we have C and A. So we already went through A, so we'll pick C this time, and now we have only one choice, so that's BCA. Now going back to the first step, we picked A, B, and now it's down for C. So we picked C. Now we again have two choices, and we'll proceed in similar way. We'll pick A first, and then B. That gives us CAB. Now we'll go back, since we have already picked A. We'll pick B, and then the only choice left is A. So that's CBA. So in the similar way, we can compute permutations of any given string. So in the next section, we'll go about how to write the Java code for computing permutations of any given word. So here's a tree that depicts the way we went about getting our permutations. So from the start, we have three options. We have A, B, and C, and then we have subsequent options depending on the choice that we picked. So if we pick D, then we have B and C as a choice, and then if we pick any one of them, we have a single choice. So we can produce all the permutations in this way. All the leaf nodes are the permutations. Alright, so it's time to get started with the code. So here's comments and some boilerplate code to get us started. So first we're importing the java.util package, which will be primarily for using the array list interface for storing the indices. So the method that we're going to use it is, let's say we have a word ABC. So it has indices 1, 2, and 3. Let me space it out a bit. Alright, so A has index 1, actually A has index 0, B has index 1, and C has index 2. So what we'll do is we'll keep a note of all the indices that have all the indices that have been considered up till now. So initially we won't be considering any indices because we haven't made any choice. So then we'll choose A first, and then we'll make 0 as the marked index as a chosen index. So we'll add 0 to the array list, and then we'll call the function again with the new marked list. So since 0 will already be marked, we have only two indices left, that's 1 and 2, and we'll go in a similar way. We'll mark 1 again, and then we'll call the function again. So this time 0 and 1 will be marked, and since index 2 is the only one left, index 2 will be marked as well. So, and then since 0, 1 and 2 all have been marked, because we use recursion, it will go back up to the point that we marked 0. So after that, since 1 has already been done, we already went that way, it will mark 2 as considered, and then it will mark 1 as considered, and in that way we'll go about the recursion technique that we discussed earlier. So first we'll have to get the word from the command line argument, and then we'll create an array list, and then we'll get the permutations. And then since we're getting the permutations, we'll display them. Alright, so this is the main method that we'll primarily be using for the command line interface. So this is the function that we're going to call recursively. This contains the entire logic of our code. So what it does is it takes a word and an array list of already considered indices. So if the word is ABC, and if the array list has the index 0, then it marks as A is already considered. So we have to look for permutations of B and C. We have to look for ways in which we can rearrange B and C to form unique words. And what it will output is an array list, which this should be string. What it outputs is an array list of string containing all the possible permutations. So first we'll create an empty array list that will be returning or populating with data that will be returning to the calling function, or whatever is calling the function. And so yeah. Right, so that's done. Then if all the characters are considered, we are done. We just have to return the empty array list, because there are no possible ways that we can go over, because there are no characters left after the word. So if size equal to length, so the length is the length of the word, we'll be adding an empty string, and we'll be returning the array list. Alright, so going ahead with the example of marking A as considered, we have to go ahead and find permutations of B and C. So what we'll do is we'll make all the possible permutations by considering B first, and then by considering C first. So if nothing is marked right, we have A, B, and C. All the three are unconsidered. So we have to find the permutations by considering A first, then for B first, and then for C first. So what we'll need is a for loop, So if the index is already considered, we'll have to return, or we'll have to skip the iteration. And if it is considered, we'll go ahead. If it is not considered, we'll go ahead. So we'll create a duplicate array list of all the indices that have been considered, and we'll pass it for the next recursive call. So we'll create new array list. Alright, so this creates a duplicate array list, and we'll add the current index since we will mark it for the next recursion. We have to mark it for the next recursion. So if we are considering A first, then we have to mark A as considered so that the next recursion call can choose between B and C. So alright, so we have to calculate permutations by performing a recursive call. So here we are passing new indices, not the old one. New indices contains all the indices in the array list that is passed to the function plus the one that we are considering right now. So by calling this function again, we have all the possible permutations for the unconsidered characters. And since we have the permutations for all the unconsidered characters, we have to add the character that we are considering right now before the permutations written by the before the permutations of the unconsidered characters. So for that we'll do permutations add. So word.var@I. So we are concatenating the character that we are considering before the results. So if we have considered A already, or if we are considering A right now, permutations will be right. So we have to make ABC and ACB. So we have to add A before the permutations. So which is why we are adding A before the permutation. Alright, so that populates our array list to return, and we'll return it. Alright, so let's try to see if this works. So I have a typo over here. Alright, so let's do it again. Permutations. Sorry, I have to compile it. Alright, so here we have to string Alright, so since this is compiled, we will call ABC, and this returns ABC, ACB, BAC, BCA, CAB, and CBA. Those are all the correct permutations of A, B, and C. So let's do something like Java. So these are the permutations. So there will be duplicate permutations within this because we have two A's. So there must be two B. So yeah, we have duplicates in this. So for removing those duplicates, we can write extra code that goes over the array list, stores all the unique ones into a new array list, and then returns a new one. Alright, so that's it for permutations using Java. Thank you for watching.